All right, it's game time. Good morning, everyone. I'm Bob Lyons, the Program Executive Officer for Weapons and Director of the Armament Directorate at Eglin Air Force Base. I am your moderator for today's panel discussing affordable munitions. I'd like to introduce the panel members participating today, and it's great to have each of you here with your experience. Just to my left here is the Honorable Shon Manasco, serves as Senior Counselor at Palantir Technologies, where he provides strategic guidance on global defense and commercial business matters. Before joining Palantir, Mr. Manasco held the position and served as the United States Air Force Undersecretary of the Air Force, acting following his role as Assistant Secretary for Manpower and Reserve Affairs, United States Air Force. Thank you, sir, for being here. Next is Mr. Mark Miller. He's a Senior Vice President and 35-year veteran of Leidos Dynetics and leads the Missile and Aviation Solutions Division, which he originally established in 1990 as Dynetics' first aerospace engineer. The division provides quick response and affordable solutions for its customers. His recent work involves developing modular, open architecture, and service common missile with United States Special Operations Command and Air Force Special Operations Command. Next is Mr. Matthew Steenman, joined Elbit Systems of America in 2024 as the Chief Technology Officer. In this role, he is responsible for guidance, vision, and strategic impact of the company's engineering and technology organization. Matthew served 14 years as an active duty U.S. Air Force officer in combat operations and as an experimental test pilot specializing in rapid aircraft system integration, modification, test, and fielding. Thanks for being here. Finally, we have Major General Steve Sargeant, who is the Chief Executive Officer of Marvin Test Solutions. At the Marvin Group, he focused on armament and armament tests supporting warfighters worldwide. Prior to leading MTS, General Sargeant served as the commander of the Air Force Operational Test and Evaluation Center, where he was heavily involved in the Joint Strike Fighter and munitions operational testing. Thank you very much for being here. And those that came to learn about affordable mass weapons, these types of munitions emphasize producing and procuring large quantities of cost-efficient, effective weapons and ammunition to ensure a country can fight and win modern conflicts by rapidly replacing expended stocks and overwhelming an adversary with a significant amount of weapons. These types of weapons are based on designs that you can get into production very rapidly. These designs and these products are forged in some of the most modern tech that's available on the earth. Artificial intelligence applied to design, 3D manufacturing, the application of software in new ways, and speed. And over the last 12 months, we have seen 6 different designs go from contract award to first flight within 4 to 7 months. And we're about to embark on the production of the first 1,000 weapons, which, if it works, will have 1,000 weapons on the shelf within 2 years of contract award. So with that as the opener, we've got a series of questions here. Mr. Manasco, Palantir excels at data integration and analysis. Given the increasing complexity of global supply chains and manufacturing processes, what are the most impactful ways data analytics can be leveraged to identify inefficiencies, reduce costs in the production and sustainment of munitions?
Thanks, Bob, and it's great to be here with my fellow panelists and back with airmen and guardians, if any of you are out there. As the leader of our international defense business, I get a chance to see this problem set across the world. And if you were to go into these manufacturing environments, here's what you're likely seeing today. You have design teams that use a collection of tools. You have technologies that are being used in the manufacturing environment that are different, by the way. You have bespoke tools and a collage of tools that are then used by your supply chains. And then it's probably underpinned by an ERP system that connects to finance. And oh, by the way, there's this thing called maintenance out there that is a completely separate set of tools. So what I see is a great opportunity for us to, across these major players, to integrate all of that data. And if you can do that with a semantic layer, now you can begin to employ AI on top of that to lean out your end-to-end process. And if you can do that effectively, like some actually companies have, what you'll see is costs go down, and then throughput be increased. And keep in mind, just take for instance Ukraine. Ukraine expends more shells on a daily basis than most NATO countries produce in a month. So this is a very important topic, and one that I think we have a unique capability to bring to bear, just as we do in other of our commercial companies that we have as partners.
Thank you, sir. Mr. Miller, with your extensive background in munition systems, what innovative techniques, manufacturing materials, beyond those traditional approaches, hold the greatest promise for affordable munitions?
So I think the top answer is one that most of you probably anticipate, and that is additive manufacturing. And it offers tremendous promise in airframe components and energetics, and the benefits to produce highly complex geometries and reduce waste, reduce tooling, with the added benefit of rapid prototyping, being able to get your manufacturing line stood up very rapidly. There's also hybrid manufacturing that utilizes additive manufacturing and other things like casting, and then removes the excess material to meet the tight tolerances necessary for weapons. And so I believe the incorporation of more casting also can't be overlooked, because it offers great promise. And then there's low-cost composites and thermoplastic materials that are also in the running. And I'd also like to say that you can't lose sight of things like traditional CNC and high-speed machining. Works pretty well for relatively simple geometries associated with some affordable mass systems. And in our desire for innovation and speed, we can't lose sight of the massive infrastructure that's already in place with conventional methods. So in preparing for this session, I researched and saw that the Bureau of Labor Statistics reported there are 130,000 CNC machine operators in the country. So if you make note that each one is probably running 2 or 3 machines, that may be 300,000 to 400,000 machines available for conventional things. And then if you believe and are pushing for affordable scale, you have to utilize our digital twin models to distribute the manufacturing across the nation, as well as to our allied partners, using all of the manufacturing methods that I cited. And that will accelerate design to production timelines and reduce testing cycles.
Thank you, sir. General Sargeant, given your experience both on active duty and also in industry, operational test, and the growing complexity of munition systems, how can we improve the efficiency and effectiveness of testing and the validation process in order to get those rapid fielding timelines that we expect?
Well, thanks for having me on the panel again this year. I think it's fair to say we can shorten the development by leveraging modular, automated test systems and digital engineering to reduce the redundancy without sacrificing rigor, because rigor is definitely needed, even though these weapons need to be fielded fast and in large quantity. I think the potentially biggest gains will come from common architectures and reconfigurable platforms that can scale across the platforms. However, it's important to use predictive AI maintenance algorithms so we can forecast the spares and maintenance that'll be needed for the planned deployments to keep them operational. And so those AI algorithms need to be developed during operational testing in the harshest environments to prepare maintenance to be able to maintain these weapons in the environments that they'll be deployed to.
Thank you, sir. Mr. Steenman, Elbit Systems' international presence, a history of adapting technologies for diverse operational environments. I'm sure you have some ideas. And in what specific areas of munitions design or production can we be most efficient to leverage modularity and open systems architecture to get those weapons faster?
Sure. Thank you very much for the opportunity to be here. I think when we talk about MOSA, it's a paramount to define MOSA at the appropriate level and not to go too far into requiring specific modularity, because you run the risk of extending development cycles and extending the cost. You know, one of the areas that we deliver a lot for the weapons industry is in seekers. And as we invest in our next generation seekers, we really look at software capabilities and enabling faster software capabilities in those updates. So we pair a processor directly behind the seeker, if you will, and we have that video pipeline that is stable and ready to go, and now the government or third-party vendors or OEMs can put their own algorithms on there and quickly, you know, as you spoke about earlier, sir, bring those weapons to field and upgrade the capabilities once they're in the field.
Thank you very much. Just want to follow up here with Mr. Miller and General Sargeant. There are these trade-offs between cost, requirements, or I guess there's assumptions about those types of trade-offs. So given the known challenges with affordable weapons and these inherent trade-offs between cost reduction, reliability, funding, legacy test and carriage systems on different fighters and bombers, and the supply chain vulnerabilities, what can be done to mitigate the operational risk given those types of trade-offs?
Well, I think we can manage the risk by building in interchangeability of designs, diversifying suppliers, and embedding sustainment planning from the very beginning. And that can be tested during operational testing. Data-driven maintenance and open architecture tests in both test and carriage systems will inevitably strengthen reliability while keeping cost in check, which I think will be very, very important to get the numbers out there in the hands of the warfighters.
Yeah, I'll follow up that with, I think our efforts to field affordable weapon systems like small cruise missiles and the FAM program and other activities require us to up our tolerance for operational risk. So legacy systems are designed for near zero failure rates, and we must accept that we can't be both near perfect and affordable. So what can we do about it? First, you can swarm these lower cost munitions to compensate for lower unit reliability. And so in order to swarm, you must have the means to launch affordable missions affordably. And that is where palletized munitions look attractive. And we have to recognize, however, that there's a delivery cost that goes along with launching an affordable weapon. And so the more munitions that you can get into a delivery platform, the better. Affordable mass needs mass. So with greater loadouts, with the munition that is just good enough, helps on both the munition unit and delivery costs, no matter what manufacturing method is used. Also, you mentioned, I think, AI. With the intelligent and collaborative swarm, you can compensate for lower reliability by reallocating units as the swarming progresses towards the target. Studies that I actually led on a DARPA low-cost cruise missile seedling effort back over 10 years ago showed that a high-low mix of munitions offered significant advantages versus just throwing one type of munition at a target set. So basically, the whole being greater than the sum of the individual components. And this is a great opportunity to utilize AI to enhance the overall effectiveness of the swarm as well.
Thank you. This is to all the panelists, and I'll start with Mr. Manasco. Many of the types of conversations that we have about affordable mass weapons, again, is this tension between performance, affordability, and scalability. Maybe that's an assumption that people make, that those have to be traded. And then there are big primes, and then there are new entrants into this area. And I'm wanted to get from each of you one or two specific initiatives or observations that you have about how companies can actively pursue making changes to their design practices, their culture, their leadership, what have you, to afford this new way of building bombs and missiles. Sir.
Well, what I would recommend the group do is really look carefully at those companies that are actually doing it well. And when I say that, meaning the production rates and the cost per are attractive, and try to find commonality in what they're doing. There's a few that I can point to. I won't name them by name, but they do extraordinary work, and that's in part because they can see themselves clearly. End to end, they can see themselves clearly, and they're leveraging the most sophisticated technologies like large language models. And as it turns out, if you have the right semantic layer, you can really leverage these tools to help you streamline the process end to end. And so having been in these environments and seeing how all of these, again, collage of tools are being used, in my mind, there is no way you're going to be able to squeeze as much cost out as you can. And there are companies that are leaning into this today. And we should also, lastly, seek inspiration from the private sector. Because there are companies that actually do this exceedingly well. And yes, there are nuances, obviously, to producing munitions that we have to take into account, but there are some commonalities across industries, whether it's the airlines or the aircraft manufacturers, whether it's, believe it or not, hospital administrations. Like, there's so many places where we can look for inspiration. And that's what I would encourage, the team to do. And the companies that are in this business, if you're going to compete and you're going to compete well, trust me, that foundational layer from a software perspective, if you overlook that, you're going to be disappointed, because all you're going to do is work harder. And work harder is not going to yield the results that we need.
Yeah, so I think I can add a little bit to that. I agree 100%. Working harder is not going to get it, but working smarter is going to help us. And I think that begins with the government and prime contractor being able to work more effectively and efficiently at the very beginning. So there's a government need and a requirement. But how do we get that defined, and then how do we get that awarded on contract more rapidly? So there's been lots of discussions over years about acquisition of form. There are other elements that have come on board, like DIU, which you're using, sir, right now on some of your programs to accelerate. I think the other thing we have found out is a company somewhere in the middle. Leidos is a big company, but we're not a major prime like Raytheon or Boeing. And we've been working niche munitions for quite some time. But we have built and fielded quantities in the thousands of niche weapons, primarily within the special ops community. And I have found that efficient working is not just between the government and the prime contractor, but having a team of suppliers and vendors that understand and are 100% on board and pulling all in the same direction. So I think the collaborative nature across the elements that are working to produce and field a munition rapidly is absolutely critical.
I looked at the problem and tried to define it as trying to solve for cost, speed, and agile lethality. So getting at those, embracing the modular open systems that we talked about, designing for scalable, efficient production, which means I think we need to use those digital engineering design models early on, not just for design and development, but also for manufacturability early on, so that when that design hits the street and ready to go to production, you don't need manufacturability engineers making it easier. That should be built in from the very beginning for the speed part of it and to keep the cost down, and then using existing armament test equipment to the max extent possible, again, lowering cost. But to know how we're doing, I think clear metrics probably need to be employed to track the expected declining unit cost that you would expect to get from doing these munitions best of breed, as was mentioned earlier, over successful lots, and then measurable reductions in sustainment expense. if you've used those AI tools early on to forecast what you ought to be deploying, both maintenance procedures as well as the spares that need to go with them.
I think largely for us at Elbit it's come down to making sure that we're following a product-centric approach. So not to go after every unique opportunity and niche requirement, but now develop a family of products where we can use modularity, but now we can also use scale, because oftentimes the price really comes down to how many are you buying, and our ability now to go buy hundreds of thousands of things instead of 10 dramatically decreases the cost.
Thank you. So in the last year, we've had a two-part strategy with our approach to munitions. The first part of that strategy had to deal with a focus on existing production lines and making those perform, getting them healthy, and to keep delivering those war-winning products. And the second part of that strategy had to do with the affordable mass as the way of filling our stocks with the latest modern tech. Now, there's an intersection between what industry does and what the government does to achieve such objectives. So I'd like to ask Honorable Manasco if he has any thoughts about how DoD and industry can better collaborate. That's one. And then two, the advice to the companies, the national assets that are out there producing weapons today, what advice do you have for them when it comes to incorporating some of these design principles for affordable mass?
So it's a great question. I would start by saying that we can't continue to expend a munition that may cost $250,000 and knock down a $30,000 drone. Like, whenever we do that, the enemy is cheering. And so from my perspective, we have to figure out a way to get the price per down. And so if that's what you're facing, and the threat is, again, Shahed drone, what kind of munition do we need to be manufacturing, right, that doesn't put us upside down economically? And that's just me, the business person, talking to everyone. The other thing I would say for those companies involved in this space, as you're standing up new lines, it's a great opportunity for you to rethink how you're actually doing that and not just replicate what you've done in the past. It's easy just to replicate, again, historically what you've done, and I think that's a big mistake, and that's where I think some of these new entrants have an advantage, because they don't have a legacy set of systems and a legacy way of doing business, and it's those companies that are, I think, setting the pace, and the large, great companies that we have in this, as the defense primes, need to look very carefully at what these new entrants are doing and start to model some of what they are doing and how they're doing it. And if we can do that effectively, then I think we'll be in a much better shape collectively.
Thanks. Mr. Miller, any advice for how to incorporate affordability, new design principles, scalability into existing production lines?
Sure, we've mentioned it several times already, and that's the embracement and expansion of full digital engineering models of your system. And so especially if you're working rapidly to spiral a capability that is good enough, then having those resources to apply can speed up the turnaround time in which new technologies can be incorporated into existing systems. Mentioned before, additive manufacturing methods for very complex components has tremendous payoff, and it is also an area, I think, where we can gather significant cost savings. Multi-sourcing of subsystems will aid in scalability and offer greater competition, and that always results in innovation and cost savings. Another thing to consider is that while the prime contractor for affordable systems will eventually get the need to compromise between performance and reliability to get scale and cost, there's a mid-tier supplier base that also has to be nudged to come along with that. That is not used to working that environment. And that's where you mentioned the big companies learning how the disruptors are using innovation to develop alternate processes to develop affordable mass, I think we have to pass down and leverage the suppliers that provide so many of the components that are integrated into these systems to think with that same mindset. So as we've worked ourselves in this area, working with our sub-partners to understand good enough means good enough is a challenge, and I think there's more work to be done in that area.
Thank you, sir. I'm going to go back to the collaboration between industry and government, specifically the test area. And the General Alvin had mentioned in the last session, he shared a story about Falco, APKWS, and fielding something within a month. A lot of that has to do with, on the government side of this, who you have leading it and what kind of resource they have. And we have a great story with the 96 Test Wing in Eglin and their ability to get that done. And having you coming from a test background, the question is, what advice would you give the Air Force, the Department, the defense contractors on ways to dramatically improve the acceleration of the testing process?
Bring money. But beyond that, streamlining the requirements early on and make them extremely clear. And once you set those requirements, stick to those requirements, so which means you've got to put the thought process, the power into it early, so what you ask for is what you really want to get. Because as soon as you start changing it, you add to that timeline and you add to the expense. Invest in shared test infrastructure. This is a team sport when it comes to I think, the DoD and industry when it comes to armament and munitions. That's where you get the lethality. That's where you get the target destroyed with all those exquisite systems that you put armament on that turn them in from great show airplanes to now warfighting airplanes. And so you need to get that done early. You need to, as you're doing these weapons, think about the armament you already have. Will they work on the armament you already have, or do you need exquisite armament? If you need exquisite armament, you need to get that designed early so that it's ready when the weapons are ready. But if you can modify the existing armament, you may have a much faster way to the enemy and delivering the lethality you want to get to. And then the other thing for Department of Defense is incentivize rapid prototyping. There are ways to do that. So I kind of opened, you might have thought flippantly, with bring money, but the reality is work your budget and your requirement hard, and you can usually get what you want faster. I'm sitting next to a gentleman here who was part of Moab and led that whole Moab effort. I'm not sure if we'll talk about that on the panel or not, but you might want to talk to him afterwards, because it certainly made headlines with our chief and the Air Force here in the last few months.
Thank you. Mr. Steenman, as you've got background in experimental test, been in industry for a while, so same question for you. What advice do you give the Air Force, the DoD, defense contractors to dramatically improve and accelerate the test process?
Agree with everything that was just said, and we talked earlier as well about making sure that what can DoD and industry do better. And I think it really comes down, one of the primary items is making sure that the business case closes. So while we talk about rapid prototyping and we can bring prototypes, to the field and test them quickly, if there's not a back-end production or business case, oftentimes, for industry, it starts to not make sense anymore to do those investments. But if there's clear path to acquisitions, industry will go in advance and test itself and bring a proven product. And I think that's a way to truly speed up the test process. That's
a lot of stuff to think about here with the different themes that you have. I wanted to ask some specific best practices that you have seen in the last year when it comes to this area of affordable mass. What are the best practices that you have seen with any aspect, whether it's the way industry approaches it, the way government approaches it? And I want to start off with Mr. Miller to give your thoughts about that. And then next will be Mr. Manasco.
I think it's along the lines of how you're executing your programs for affordable mass now, is to foster competition, fly early, fly often, and evaluate the results of those to make smart decisions for the government. The other thing I think that I wanted to note on the earlier question is something that I think we might have glossed over is in developing new affordable mass and systems, making sure that we design with existing aircraft infrastructure. The cost of the weapon development can be prohibitive. The cost to integrate the hardware, if it requires changes to the platform, is prohibitive. If you start talking about the cost to alter the software to launch the weapon on the hardware, then it becomes extraordinarily difficult. So we have both the open systems and architectures on affordable mass, but those weapons have got to conform to the infrastructure to facilitate the speed and lower the cost for integrating and fielding the weapon system.
So I might sound redundant here, but everyone, I love the idea of digital engineering. It's great, but when you look at this in practice in a lot of companies, there's one part of their enterprise that is focused on digital engineering. But if you can't connect design, manufacturing with your supply chain and your maintenance, connecting that to your financial systems, and doing that in an integrated way with a semantic layer and leveraging modern technology, that's the difference between those that are doing it well and those that are continuing to struggle. And that might sound spicy, but that's what I see day in and day out. And two other things. One is, and I would say this for the government and for companies, private companies, you should buy what you can and innovate where you must. And so all too often what we try to do is say you find a great commercial product and then you'll have an internal IT team say, you know what, I think we can build it ourselves. How many times have we seen this and the story never ends well. So what you should do is buy what you can and then build on top of that, right? So that you're not throwing precious resources at a problem that's already been solved and it's already been proven. Period, full stop. Take those precious resources and apply them to the next new problem that has yet to be solved. And if that one kind of theme resonates with you, at least I hope it does, that's the difference between, from what I see, those that are doing it well and those that are continuing to struggle.
Thank you. Mr. Steenman, any thoughts?
I think what's really important to maybe take a slight tangent off of that is making sure that we're designing for availability. So not only designing for cost, designing for manufacturing, but looking at what's available, especially when we talk about mass. What can we go purchase in mass to incorporate into the weapons and make them function appropriately?
You know, one of the observations in the last year is we've been able to see designs with a lot fewer parts, a lot less tooling required to produce those parts, and not just from one place, but from multiple. What is it about what's going on right now in human history that makes that possible? Mr. General Sargeant?
So one of the things is integrating reliability engineering early on in the process. We're talking about digital manufacturing, et cetera, but reliability engineering, doing that piece early on, as well as using some of the AI-enhanced tools out there to make sure that the life cycle, because you're going to have a lot of modules, and we didn't talk really about the family of modules for range and warhead, but you're going to have a lot of those, and you need to balance cost versus reliability, because if cost becomes too big of a factor, then risk is going to go up that you're going to incur obsolescence early on. You're going to get lighter weight parts than what you probably need for the long haul. For storage and that sort of thing. So reliability engineering early on will help solve some of those problems and avoid them in the future.
Thanks. Mr. Miller, any thoughts?
First, and I don't get a commission in this, there's a great book out there called Freedom's Forge, if you haven't read it, that touches on so many of the things that we've talked about today. And I think we figured this out about 75 years ago. We had to scale up for World War II. And as we talk about all these things about digital models, and I've said digital models, what, 3 or 4 times? Don't think we had any digital models back then. They were pretty much analog and on paper. So we can't discard the common sense approach to smart and innovative engineering and the ability, when you look at speed and you look at affordable mass, to be able to share the workload, like you mentioned. Don't create something new if somebody else already does it and does it well. So being able to distribute your manufacturing across a number of reliable, solid, proven performers versus being the unified, one company does all, I think is a key element. If you even go back to the example of the Liberty ships, how they were built in pieces and then put together in one instance an entire ship in 1 week. So I think it behooves us to leverage the models and the AI and the things we have, but there's an element of going back and understanding how we brought in the full depth and breadth of American industry to meet the challenges that we face again today.
Good points. Mr. Steenman, any final thoughts?
I think as we move into the future, it's important that we make sure that we're designing our weapons so that they can be upgraded. I think software functionality and capabilities are the way of the future. And maybe while we haven't done that a lot in the past, I truly believe that will enable us in the future.
Okay. So I want to thank each of you for your insights, your service, your experience. In this room, you have many people that work on affordable mass weapons today. You have people in here that work on existing production lines around the country. We have the Chief of Staff of the Air Force in the room today with us. Thank you for being here, sir. Mrs. Alvin, thank to see you. 96 Test Wing commanders out there. And we have the Weapons Capacity Task Force at Eglin in here. There's many more. And we owe a great deal of credit to the people that preceded us that set in motion the modularity, the open systems architecture. And the only reason that we're in the position today to do this is because of the people that made that possible. So I want to thank them too. So with that stated, if we have one very, very brief comment, last thing that's on your mind, and then we'll wrap this up. So Mr. Steenman?
Agree completely with what was said before. We didn't have digital models in World War II, and common sense is still important.
Right on. General Sargeant?
Operational test is paramount, and make sure that you're doing it in the most severe environment you're going to operate in. Not the one you think you might, but the ones that you're going to operate in because you need to get them into the field fast.
Affordable mass is more than just about the cost of the item that you're launching. You have to look at the entire cost to deliver that unit per target. And we can't lose sight of the element of just not looking at the unit price of the weapon, but the total cost, including the aircraft and the crew risk to put that weapon on a target.
And I would just say, never send a human to do something that a machine can.
That's fantastic. So I want to thank the panelists again. Let's give a round of applause.